Now we want to find an expression for the distance between the points 2, 7 and xy. Now, if you haven't already seen this, you should think about that. In any case, we can represent this situation. We can put 2, 7 at some point, and xy could be anywhere because we don't have a scale on this graph. So I'm just going to put xy here for a change instead of up here, up and to the right. Okay. Now, from 2, 7 to xy, what's the rise? Well, from here to here, the rise is y minus 7. It's always the second point minus the first. If the points really are in this relative position, and we have the traditional y-axis up, x-axis to the right, then y minus 7 here is going to turn out to be negative because y is going to be less than 7. So when we subtract 7 from a number less than 7, we're going to get a negative, and that fits with the fact that we're going down to get from here to here. And then we're going to go over, and if x is to the left of 2, then x minus 2 is also going to be negative. So we do y minus 7 for the rise, x minus 2 for the run, from here to here. Now, as far as finding the distance, it wouldn't matter if you went from here to here. That would be perfectly all right, but you'd be, your notation would be opposite the notation you usually see. But since you're squaring these quantities, it makes no difference. So if this was 7 minus y and this was 2 minus x, it would be okay because they're squared. You're going to come out with the identical result when you square them. So anyhow, there is the expression for the distance, because all we do is use the rise and the run with the Pythagorean theorem, and there we have it. Now, what about the statement the distance is 5? What's that mean? Well, this is the distance, and the distance is 5, so that this expression is equal to 5. I won't read it to you. You can see it perfectly well. Now, don't really want that square root in there. It's going to be much easier to manipulate these equations, and we will often manipulate them. If you just square both sides, and that's perfectly valid, you get y minus 7 squared plus x minus 2 squared equals 25. That is the equation for the condition that the point xy lies at 5 units from the point 2, 7. Now, if this is the point 2, 7, and I kind of inserted something down here, so ignore these equations and stuff, but if this is the point 2, 7, and here's an xy at a distance of 5 from the point 2, 7, can you show me another point at distance of 5 from that, from the 2, 7? Well, we can easily measure that distance. It's from my thumb to the end of the paper, and then I can find another point down here. Now, all I asked for was another point, so at that point we would just draw a point here and we'd have a point here. But now we see that if we simply sweep this out, we get an infinite number of points, and we get an arc. Now, if we do that for all possible points that lie at distance 5 from 2, 7, what do we get? Well, we get a circle of radius 5 centered at 2, 7. I'll write that off the board so you don't have to sit there and watch me. So I say that all such points form a circle. And more than that, it's a circle of radius 5, and that circle is centered at the point 2, 7. And so I've written that in. And that circle has this equation. So here's the equation. Of the circle. Either of these would be an equation for the circle, because all this equation says is that the distance from 2, 7 to xy is 5. Okay, there's the distance is 5. Squaring both sides, we get a completely equivalent equation.